Okay, any questions? So does that make more sense? Alright. Good. So now we're going to take everything we've done and we're going to talk about proportions. So here's the topic we want to investigate. Does the public believe the death penalty should be used? Specifically, we want to find out if a majority of Americans support the death penalty. We survey 120 people and 67 say yes. What can we conclude? So, what kind of question is this? This is a hypothesis test question. So the first thing we do, that's right, you write your hypotheses. So, what are the hypotheses? Well, go to this question, what's the claim? Just in words, what's the claim in this question? Right. Okay. So there's the claim. A majority of Americans support the death penalty. How do we say that in math? No. You're looking somewhere else on the problem. We're literally going to take that sentence and translate that into math. So the main thing here is majority. What does majority mean? Sorry? What is majority? Just in English. What does majority mean? It does not mean most. Majority has a very clear definition. What does majority mean? More than half. That's what majority means. Right. Yes? Okay. So, majority means something, well, more than half. Obviously, we have to fill this in. Something is more than half. What's more than half? Sorry? The rate? Oh, greater than, yeah, right. So we got something greater than half. So what's greater than half? Okay. So Sode says mu. Are we taking an average? We are not taking an average. What's another way of saying half? 0.5. Right. So in fact, that's how we're going to be writing this, as 0.5. So this is not a mean. We're going to write it as greater than 0.5. So we're not talking about means. What are we talking about? This is a proportion. Now the way we typically, in common language, we usually talk about things in terms of percentages. But in math or in stats, we talk about things in terms of proportions. So for example, when we say greater than 0.5, as a percentage, what would that be? What is 0.5 as a percent? It's greater than 50%. So what we're used to thinking of this is more than 50%, but in math we're going to write down greater than 0.5, and this is a proportion. Now, what's the notation for proportion? It's P or P hat, right? So we got to figure out which one. Okay. It's true, these are both proportions. Yeah. P is which proportion? No. What's the meaning of P? It's the... Which proportion is P? One's for the sample and one's for the population. Yes. Which is which? The top one is what? Population. So P is the proportion of the population. Say that 10 times fast. And P hat is the proportion of the sample. Now, what are we making a claim about? Are we making a claim about the population, or are we making a claim about a sample? No. Yes, 67 out of 120 is from the sample, but are we making a claim about a sample? No. We're making a claim about all Americans. That's a population. So this claim is about P.
How do you know if you're using P or the other one? This is the sample population. No, but like, how do we know if we're using P instead of the other one?
Which other one?
Instead of the one that you said before.
Mu?
Yeah.
Okay. So that's a big thing that we're going to talk about in 1 second, after we write down the claims. Okay. So what we're claiming is that the proportion from the population is bigger than 0.5. Now, is that HO or H1? That's H1. So what is HO? P equals 0.5. Okay. So, in a lot of these problems, unpacking the question and simply writing down your hypotheses can be one of the hardest parts. Alright. Now, one of the things that you need to do while you're converting it to notation has to do with what Albana just asked me. She said, how do we know this is about a proportion and not about a mean? So how do you know that? Okay. Yes, there are a couple of clues. First of all, the question asks about a majority. Now, when you talk about a majority, is that a mean or is that a proportion? It's a proportion. Also, if it helps to remind you about classifying which is which, a proportion is basically the same thing as a percentage. So when you're talking about a majority, you're talking about an average, or you're talking about a percentage? You're talking about a percentage. So that's a proportion. That's the first clue. The second clue is going to come from the sample. So let's work with the sample for a minute. So you guys are quite right. We also have a sample here. So we need to figure out our data from our sample. What can we get from our sample? Well, by this point, as y'all I think have figured out, we're going to get P hat. P hat is the proportion from the sample. What is P hat? Okay. P hat is a proportion. Is P hat 67? Is 67 a proportion? No. So if we ask 120 people and 67 say yes, in what way can we make this a proportion?
Divided by 120.
Exactly. This is 67 out of 120. Now, what will be helpful for us is for our calculations, we're gonna want this as a decimal. As a decimal, this is 0.5583. So notice that that's about 55%. So now another thing to ask to answer Albana's and an important question is this question about means or about proportions? So if you said I did a survey and I got 67 people said yes, does it make sense to say that on average I get 67 people? That doesn't mean anything. Why doesn't it mean anything? 67 out of what? If it's 67 out of 68, that's pretty overwhelming. But if I said 67 out of 10,000, not so much. So when you find when you find that in order to make sense out of a question, you need to say something out of something. Is that a mean or a proportion? That's a proportion. Okay. Also, in general, yes/no question. This is a yes/no question. Does a yes/no question give you an average, or does it give you a proportion? A proportion. Think back to the actual data. You've got 67 people saying yes, and then also 53 people saying no. So what's your data? Your data is yeses and nos. Are you going to take an average? What's yes plus no divided by 2? Exactly. So there's no average here. What you're saying is a certain percentage of the people said yes. That's a proportion. Does that answer your question? Okay, and then some. All right. So we've got that. Okay. Next, what should we be writing down? Sorry? We need our mean and our standard deviation, but we don't need, what's the notation for the mean that we want? It's mu for p hat. Now what is mu for p hat? Yes, where does it come? Mu for p hat comes from where? It comes from p, the population, which is 0.5. Now what else do we need? Right, and what's the notation for the standard deviation? Sigma for p hat. And how do we find that? Right. This is that formula. Divided by what? Divided by, it's p times 1 minus p divided by n, which is 120. Right. We have to work out what this is. And get 0.0456. Alright. Now what? Yeah, now we need to say, is it normal? So how do we find if it's normal? Right. So remember, this is a problem about proportions. So when you're dealing with proportions, how do you find if something's normal? That's just that's the NP1 minus P. $30 is greater than 10, so you're good. So now that you know that it's normal, what do you do? Draw a picture. So here's the picture. What do we label? Zero in the middle for what? Z. Next. we're going to have z values, and we're also going to have what kind of values? P hat values, absolutely. So for p hat, what number goes in the middle? Right. The 0.5 goes in the middle because why? Because it's the mean. What other value do we mark off? What is another p hat value? .5583, right? Okay. So 0.5583. And then what do we do? Shade where? Shade to the right. How come to the right? Because this is a greater than question. Okay. Here, shade to the right. Okay. So we've got that. Now what do we do? Find the z-score. Okay. So we've got z equals what? Divided by what? Right. Divided by the standard deviation, which we just found. Okay. So now let's work this out. Get and you get 1.2785. And I'm running out of room. So in the interest of agreeing with the textbook, I'm going to take z to two places. So that's going to be 1.28. Sorry? Yeah, sometimes I'll try to, obviously we can be as accurate as we want, but we're going to start to have this problem of trying to agree with what the answer is on the online publisher website. So notice that the publisher website takes z to two places and takes the probabilities to 4 decimal places. I'm going to sometimes try to agree with that. Okay. You don't have to. Feel free to be absolutely as precise as you want. Let's just say this is the minimum. All right. So now what? Find the area. Okay. Equals norm s dist of 1.28. And there you go. So this 0.8997, and let's also fill in the area of the tail, which is 0.1003. So now what are we ready for? What next? Conclusion. So what's the conclusion? We are
0.8997
that, right, H1, and what does H1 say? P is greater than 0.5. Okay. And for this problem, I'd like to also convert this into English in terms of the original question. So we're 0.8997 confident that what? There you go. Okay. And let's go further. What is your p-value? What's your p-value? Right. And how do you state the conclusion using reject accept? We reject, nope, reject HO. With 0.8997 confidence. Okay. And again, you can switch the words around. You can say, we are 0.897 confident that we can reject HO and accept H1. That's fine too. Okay. So there you go. Okay. So was that straight? Any questions? All right. So why don't you guys work on this question? And if you have some magical technology way of getting the probability at the end, that's great. If not, just work up until that last step, and then we'll do the last step together. Okay. Okay. Yeah. So let's talk about this. What do you do? Okay. So what's the claim? Well, 0.6 is a number, not a claim, but it's a good start. More than 0%. Okay. So how do we write that down for HO, H1?
HO equals P equals 0.6, and for H1 P equals greater than 0.6.
P greater than.
Yeah.
Right. Okay. So what else? What next do we need to write down?
Mu with the P hat.
So mu for P hat, and what's that going to be? That's 0.6. And then?
Sigma with P hat.
And what will this be?
Square root of 0.6 minus 1 minus 0.6 divided by 1.
So you work that out, and what does it give you? Doesn't sound right. Let's check. Equals the square root of 0.6 times 0.4 divided by 180, and that is 0.0365.
Okay, I have a question. For the other question, you divided one. I forgot what it was, but pretty much 119 divided by 180 to get the 0.6.
What?
If you go up there.
Previous question.
Yeah.
Okay.
So you divided 67 divided by 120, you got 0.75. What's that for?
Yeah, what is that for?
P hat.
Yeah.
What's P hat for?
What's P hat?
Where do we use it on there, though?
Okay. Well, let's look at the picture. Where does that go?
Oh, okay. Instead of
Right. Okay. So far we've got this. Now what do we need to ask? Is it normal? So is it?
Yeah.
Yes. Okay. You do 180 times 0.6 times 1 minus 0.6, and is that at least 10? And you get something 43 something or other, which is bigger than 10, so you're good. Okay, so now what? Draw your picture. So we drew the picture, and now what? Okay. 0 in the middle for z, and p hat. Now what p hat values do we put down? 0.6 in the middle. And right, we didn't. Well, we haven't written down yet our p hat value. So we need to find p hat. So let's go back and do that. What's p hat? How do we find it? Yeah. It's the proportion from the sample. And what happened in the sample? 119 out of 180. And you work that out, 0.6611 exactly. So we put that on the picture as well. And now what do we do?
Shade into the right.
Shade to the right. So there's our picture. Now what do we do? Find the z-score. Okay. So z equals what? How do we set it up?
0.6611 minus 0.6 divided by 0.0365.
Right. Value minus the mean over the standard deviation, and that works out to be what? Anybody? Okay. Oops. Equals. Okay. 1.674. So again, I'll stay with the convention in the textbook z score to 2 places, and we can 1.67. We can fill that in on the picture. And now, find the area. Equals norm dist. This is the part where at this moment you need me. So norm s dist of 1.67, 0.9525. So this part is 0.9525, and let's also label the tail. And how do you get the area in the tail? 1 minus. So you do 1 minus, you will get 0.0475. Now, conclusion. What's our conclusion? Uh-huh. And in English, we are 95.25% confident that more than 60% of the population supports legalizing gay marriage. And p-value 0.0475. Okay, is that straight? Alright, so we've got like 1 minute left. So give you something even a little bit easier. Work through this problem. So how do you do this problem? What's the first thing that you do? No. Okay. Normally you'd write down your hypotheses first, but guess what? They're already there. That step's taken care of. So the next thing you should be doing saying what's my mean for p hat? And that's 0.62. And what is my sigma for p hat? Divided by 300. And what does that work out to? 0.0280. Okay. And the next thing you need to check is this normal? Yeah, 280.62, 1 minus 0.62. And is that at least 10? And sorry, quite so. Okay. 300. And that works out to something, but it is 78 something or other. It's certainly bigger than 10. Okay. So now we're good. So now we can draw the picture. So when you draw the picture, 0 in the middle for z. We've also got values for p hat. Which p hat value goes in the middle? 0.62, because that's the mean. What else do you mark off? 0.54 and shade to the left. So now we have to find the z-score. So z equals what? 0.54 minus 0.62 divided by 0.0280. And that works out to negative 2.86 if you round it to two places. So now we find the area. Equals norm s dist negative 2.86 0.0021. So the area in the tail is 0.0021. The area on the other side, the fat middle, is 0.9979. So finally, conclusion. We are what? 0.9979 confidence that p is less than 0.62. That's it. What does that mean? In this problem, nothing, because that's how the problem was stated. Okay.